This video should help you with your questions for your assignment for Module 2 on Assignment 2.02, Polynomial Functions of Higher Degrees. First thing we're going to do is find the zeros. So remember that zeros, that word is the same thing as solutions. Okay, so we use that word often, solutions. You may also hear it referred to as roots. But essentially on a graph, they're nothing more than the x-intercepts. So zeros, solutions, roots, x-intercepts are pretty synonymous in mathematics. So I notice here first off that I'm working with a quadratic. So if I'm finding the zeros, the solutions, roots, x-intercepts of a quadratic, I can either factor it or I can do quadratic formula. I'm actually going to use the diamond box method and see if it can be factored. So if I multiply 2 times 7, that gives me 14. That goes on the top. And here I've got 9. That will go on the bottom. So I'm looking for the two numbers here that will multiply to be 14 and yet also add to be 9. So I can quickly tell that 7 times 2 is 14 and 7 plus 2 is 9. So those are my answers. Since the leading coefficient is not 1, I do have to go one step further. Now there are a bunch of different ways that you can factor this in different methods. Don't feel like you have to use the way that I'm doing. I'm just doing the way that I'm most comfortable with. So I got my first term and my last term, and then the two that I just found, 7x and 2x. So moving vertically here, I can factor out a GCF of 2x. Moving vertically from here, I can factor out a GCF of 7. Going horizontally across, I can take out an x. And going horizontally across the bottom, I can take out a 1. So therefore, it factors to become 2x plus 7 and x plus 1. And if you're not sure how to do that, or if you factor differently, you should get the same answer. If you're not sure how to factor, definitely strengthen your factoring skills, but you can also use the quadratic formula to go ahead and skip all these steps and get your answers. So what I'll do is take each factor. So here I got 2x plus 7. I'm going to set it equal to 0 so I can solve it. I'm going to minus 7 on both sides and get 2x is equal to negative 7. Then divide both sides by 2, and I end up with x is equal to negative 7 over 2. Then I'm going to do it again with the x plus 1. I got x plus 1. I'm going to set it equal to 0. Again, minus 1 on both sides. And I get x is equal to negative 1. So because my exponent, the leading exponent here, and my degree of the polynomial is 2, I should only have 2 zeros, and I do. Negative 7 over 2 and negative 1. Here I have another question just like it, but now it's got a degree of 3. So whenever the degree is not 2, the first thing I'm going to do is look for what's called the GCF. Remember, that's called the greatest common factor. So if I look here, let's start with the numbers. I got 4, negative 28, and 48. I know I can take a 4 out of there numerically. That would be the greatest numeric GCF. But now we look at the variables. I got x to the third, x to the second, and x. So I also know I can take out an x. Once I take out a 4x, that's going to leave me with x squared minus 7x. And then 4 goes into 4 goes into 48 12 times, so positive 12 with no x. So let me change colors here. What I want to do now is I want to see if this guy can be factored further. So I'm going to go back to my diamond method. Product of the first and last, or you may have heard AC method, A times C. So that will give me 12. And then the middle term of negative 7. So I need two numbers that will multiply to be 12, but also add to be negative 7. So I'm going to do negative 4 and negative 3, because a negative times a negative is a positive. So negative 4 times negative 3 is positive 12, and negative 4 plus negative 3 is negative 7. Since my leading coefficient here is 1, I don't need the box. I know that this can go ahead and be factored into x minus 4 and then again into x minus 3, my two middle terms. So don't forget, though, that you still got this 4x that you took out, so it needs to come on down. So that way, let's change colors again. When we go to the next step, we're going to take each one, including the 4x, and set it equal to 0. So in this 4x equals 0, we'll divide both sides by 4, and we'll get x is equal to 0. Do the same thing again with this one. X minus 4 equals 0. We can add 4 to both sides, and we're going to end up with x is equal to 4. And then lastly, x minus 3 is equal to 0. Add 3 to both sides, and you wind up with x is equal to 3. So notice that my degree, again, from the beginning was 3. So I should have 3 zeros, 3 solutions. So that would be x equals 0, 1, x equals 4, 2, and x equals 3, 3. So there are my 3 solutions for this one. So then you have to find the zeros of a polynomial function and called state the multiplicity. Don't let that word throw you off. It just means how many times is that going to be happening. So this one already has been factored. So if you take this first one, this 5, you can actually go ahead and just kind of forget about for the purposes of this question, because if we distribute it back out, it's still going to give me the same answer when I set it equal to 0. So I end up with x minus 3 squared. I'm going to set it equal to 0. It's the same second step after we factored in the previous two questions. Then I've got x plus 3 squared is equal to 0. So let's change colors here so you can see the differences. I'm going to go ahead and square root both sides so I can get rid of that square. So they're gone. So I end up with x minus 3 is equal to the square root of 0. The square root of 0 is still 0. I'm going to add 3 to both sides. And I get x is equal to 3. As far as multiplicity goes, remember that's the part most people struggle with. It had an exponent of 2. So really this whole thing happened twice. So my multiplicity is going to be 2. So I'm going to do the same thing on this other problem over here. I'm going to square root both sides. They're gone. I get x plus 3 is equal to 0. I'm going to minus 3 on both sides. And I get x is equal to negative 3. Again, it had an exponent of 2, so that means this whole thing happens twice. So my multiplicity on this one is also 2. Let's just say, for example, that the exponent had been 4. Same process, I would have fourth rooted both sides, and my multiplicity would have been 4. If it had been cube rooted to the third power, been cubed to the third power, I would have cube rooted both sides. Cube root of 0 is still going to be 0. And I would have been a multiplicity of 3, because it happens 3 times. Then you're going to have to create your own functions. So find a cubic function with the zeros of radical 11, negative radical 11, and 13. This is a lot easier than it actually looks. So remember that if the answer is positive radical 11, I must have had a factor of x minus radical 11. Because remember, when I set that equal to 0, I would have added this negative 11 to both sides, and I would have gotten this answer here, positive radical 11. So if I have an answer of negative radical 11, that means I have a factor of x plus radical 11. And then if I have an answer or a 0 of 13, that means I had a factor of x minus 13. So I hope that part makes sense to you, because the next part is going to make it even better. That's the whole first step, is just rewriting them as factors instead of zeros. So what you're going to do is you're going to multiply the first two together. X times x is x squared. X times radical 11 is positive radical 11 x. And then negative radical 11 times x is negative radical 11 x. And negative radical 11 times positive radical 11, the radicals will just go away. And negative times a positive is a negative, so it's just minus 11. we can simplify this. Plus radical 11x minus radical 11x will just go away, leaving me with x squared minus 11. Then I'm going to multiply that by this other one over here, the x minus 13. We got to do all of it, which makes sense because we're looking for a cubic function. So remember, cubic is anything to the third power. So x squared times x is x cubed. X squared times negative 13 is negative 13x. Negative 11 times x is negative 11x. And negative 11 times negative 13, please keep in mind negative times a negative is a positive, will give me positive 143. Nope, I forgot my squared here on this x. Okay, and then checking to see if any like terms. I got 3, 2, 1, none as far as the exponents go. So there is a cubic function that will produce the zeros of radical 11, negative radical 11, and 13. All right, last but not least, using Pascal's triangle. This is one that a lot of people struggle with, so you want to pay attention because it's not as bad as you might think that it is. So first thing we want to do is remember how Pascal's triangle works. So you're going to start with a 1 at the very top. One triangle, one number. And then what you're going to do is you're going to keep these ones kind of on the outside. Okay? So the next, on your next row, you're going to keep your outside ones, and these are ones. I know they look funny when I'm drawing them, but you want to add the two together. 1 and 1 make 2. So my next row is 1, 2, 1. Okay, on my next row, I'm going to have my 1 and my 1 on the outside, but this time 1 plus 2 is going to be 3, and this 2 plus 1 is also going to be 3. So for my next row, again, I'm going to keep my 1s. And this time, 3 and 1 make 4, 3 and 3 make 6, and 3 and 1 make 4. So see the pattern? So next row, again, keep my 1s on the outside. 4 and 1 make 5, 6 and 4 make 10, 6 and 4 make 10, and 4 and 1 make 5. Let's do another row for good fun. 1s on the outside. 1 and 5 make 6, 5 and 10 make 15, 10 and 10 make 20, 10 and 5 make 15, and 5 and 1 make 6. So just for a quick second, pause the video and see if you can figure out what the next row would be, just to make sure you're comfortable making this triangle. So click the pause, try it on a sheet of paper, and then see if you get the same one, and then I'm going to go over the answer. So on the next row, again, we're going to begin with our 1s. 6 and 1 make 7. 6 and 15 make 21. 15 and 20 make 35. Again, 20 and 15 again make 35. 6 and 15 make 21. And 6 and 1 make 7. So that one there. Okay, so now that you've got those, how do we actually use that information? Well, that's a great question. So in this case, I'm looking for the fifth. So here's what you need to know. The very first row, we call that row 0. I'm going to label this row number so I don't have to keep writing row over and over and over again. 0. This will be row 1, 2, 3, 4, 5, 6, and 7. So I'm looking for the fifth power, so I need to go to the fifth row. So this is the row I need to work with. If I could get it to circle. There we go. So let me change colors again. So here's what we're going to do. So fifth row, these are the coefficients that I'm going to be working with. So I'm going to write out 1, 5, 10, 10, 5, 1. Now you're going to see a lot of teachers do these different ways. I like to just do it step by step and piece by piece. And so feel free to use my way, or if you learn another way, go for it. So the first thing we're going to do is I'm going to take this first value, which is x, And remember, this is technically a plus b according to the lesson and by definition. So what I'm going to do is the first term always counts down. So it's x to the 5th, that's the number we start with, the 5th power, and counts down to 4, counts down to 3, counts down to 2, counts down to 1, and counts down to none. So that's my middle term. So I'm going to use a lot of colors here because it's really going to be helpful, I think, in looking at the overall. All right, so my next term, 7, is actually going to whatever is in that spot. In this case, my example is 7, will actually count up. So it's going to start at 7 to the 0, 7 to the 1st, 7 to the 2nd, 7 to the 3rd, 7 to the 4th, and 7 to the 5th. So notice that the number of terms that I have each time matches the number of numbers in the row. So that should happen each way. So now what do we do next? Here's where the fun part comes. And again, everyone does this a little bit different. This is just the way I like to do it. To get my final answer, what I do is I multiply everything in each column. So 1, x to the 5th, 7 to the 0. Anything to the 0 power, remember, is just 1. So really this is just going to become x to the 5th. So I'm going to do that each time. Now I'm going to multiply this column together. 7 to the 1st power is 7. 7 times 5 is 35. X to the 4th, and it's positive. 35, x to the 4th. Next column. 7 squared is 49, times 10 is 490, x to the 3rd, and that's positive, because the 490 is positive. 490, x to the 3rd. So hopefully you're starting to see a little bit of a pattern. It's almost like a puzzle that you're keeping together, because now you're going to do 7 to the 3rd power, which is 7 times 7 times 7, which is 343, and that's times 10, so that's going to be positive 3,430, and then you've got your x squared. Then this one here, you got 7 to the 4th power, which is 7 times 7 times 7 times 7, which is 2,401. That's positive, 2,401. Then you got your x1, so your x value. So that one's done. Then last but not least, you've got, oh, well, actually I made a mistake on that one. That's not the correct number. I didn't finish all my steps, so hopefully you caught that. So you got 7 times 7 times 7 times 7, which is 2,401, and then I forgot to multiply it by the 5, this coefficient here, this constant here, the 5. So multiply that by 5, and I get 12,005. Sorry about that. Got a little overzealous, so don't make the same mistake I just did. You should get it right the first try. Now we can go to the last one, which is 7 to the 5th. So you got 7 times 7 times 7 times 7 times 7. And you get 16,807 times 1, which is also 16,807. And x to the 0 power is just 1, so that times 1 is just itself, so no x's. So this is the answer when you have x to the 7th multiplied by itself 5 times. So hopefully that helps you out with this lesson. If you have any questions, feel free to reach out. Thanks.